Hey guys, Mr. Hong here with a new video talking about exponential models in a recursive form. So today you're going to know, or you'll learn, how can you use this model to help you find like patterns and stuff like that using the exponential model, which is called recursion. And before we start this, before we start talking about the really heavy part of the lesson, we need to first define key points. So we are starting with this box right here. Sometimes you can see the pattern in a sequence by comparing each term to the one that came before it. So, for example, in the sequence 133 to 130 to 127 to 124, each term after the first term is equal to, well, how do I get to 133 to become 130? Well, all I did right here was subtract 3. And that pattern still is consistent or true because 130 to 127 is still subtracted by 3. So we can conclude that we just subtract 3 or is equal to 3 less than the previous term. So all these jumps right here are from from the first term to the second term, second to third, they're all just minus 3 for each step of the way. So a recursion definition for this sequence contains two parts: the initial condition which is also known as the first term, which A1, or the first term, is 133. And I got this 133 from this 133 because it was the first term. It was the first number given to me. That's what we're working with from the beginning. And part 2, the recursive formula. And this relates each term after the first term to the one before it. So the equation goes like this: a n minus 1 minus 3 for n is greater than 1. So what this really means is that the term before it, minus 3. So this minus 3 is from, let me change my color. This minus 3 is right here. This part is talking about, this part right here is talking about the terms before it. The first term to the one before it. So yes, it looks confusing right now, but it's actually very simple. And once we start taking this blue part, can you see my cursor? No, you can't. Once you see this blue part of the equation, and we replace it with like something more realistic, it'll make a lot more sense. So for us to really do this, there's two choices that you can do it, but you're responsible for knowing both. So both recursive and explicit. You must know both types. For you to know, for you to say, I learned this in an Algebra 2 level. So I'm not going to read you these differences, but pretty much know that the recursive one is talking about a multiplying. You multiply something from the previous term to get the current term. So this is previous. This is current. And the R, this R right here, is rate. And we're going to talk about the rate in example problems. So the explicit formula, which I guess you can't see my cursor again, but the explicit formula is another version of the recursive, but this is used for um, more like multiply heavy rates, and we're gonna see the differences between these, but we're gonna be able to come up with the same answer, but written differently. Just like how we can say that, we can say that 3 over 4 is the same as 75%, or 0.75, or 75%. We can say that all three of these things are saying the same thing. So the recursive formula and the explicit formula, they're going to be saying the same thing, just differently. So let's look at the example 1. Example 1 is talking about a table that shows a number of visitors to a popular website over a period of several days. Write the explicit formula and the recursive formula to model the data. So we have the data, and they want us to first convert this into a data point, or of a table into a formula. So the first thing I need to do is find my initial term, which is actually here. This is my initial term. So A1 is equal to 11. Ooh. And I'm going to write it on both sides because both of them are useful because of this right here. What the heck? Okay, hold on. The music is a little loud. Actually, hold on. Give me just a moment. Okay, that's better. That's a better song. More peaceful. Okay, so I'm going to do the recursive formula first because it's a very easy equation that we can do, where we have to find the rate. Well, we don't know what the rate is, but I know that here from 1 to 2, how did I get to 11 to become 44? What did I multiply, add, divide, subtract to become 44? So let me put an Edpuzzle question here, which is at 735. Okay. So the rate right here, or what I multiply this, was times 4, which is pretty easy. So I'm going to put my R equal to 4. I don't need this question mark anymore. So now all I gotta do is write AN is equal to 4 times AN1, or N minus 1. And this is my answer. Very simple. All I had to do was find this rate, which was times 4, which is right here. I guess I should write this times 4 like this. Multiply. There you go. Know that I wrote the AN minus 1 and the AN exactly the same from the equation. So this, if I clean this up a little bit, AN is still right here. The 4, of course, is the rate. I have to change that depending on the problem. But this AN minus 1 is talking about the previous term. So if I try this out, if I try to plug in this equation, it becomes, well, 44 is equal to, because this is term 2, this is 4 times, what's term 1? Term 1 is 11. And this is true. And this will be true for all of them. So this is why this is the recursive formula, a way for us to formulate the pattern between the visitors or the data shown for us. So if that's true, what about the explicit? So the explicit is more, not too difficult, but we're going to be talking about how we can use exponents to help us write another formula. So we can say that A1 is 11, A2 is 44 because A1, A2, these are talking about the terms. So if I use the same color, A1 is a 1, A2 is 2, A3 is equal to 176, which is this, and so on and so on. Okay. So what happens really is that I want to write this over here. A3 equals to 176. Okay. And the reason why I want to write that is because I can say that I can do 11 times 4 to the power of 0. This is equal to 11, right? Because any number to the power of 0, this is equal to 1. So 11 times 4 to the power of 0 is equal to 11 times 1, which is 11. So 11 is my answer right here for this equation. But what about 11 times 4 to the power of 1? That's 44, so that's still true. And if I do 11 times 4 to the power of 2, then this becomes 176. So this is still true. So in the end, we can use this explicit formula right here. And since I have, well, when you use the explicit formula, you have to either decide, okay, do I have the initial or do I have another initial? So we're going to use this one because we know what A1 is. We don't know what A0 is. Because we have day 1. We don't know how much day 0 is. We have day 1. So we're going to use AN. I'm going to erase this orange part so I can highlight stuff. AN is equal to A1, which we know what A1 is. A1 is 11. So we're going to write 11 times, we know what the rate is. The rate is 4. And we're going to put n minus 1. We don't know what n is equal to. We never do. We're just writing a formula so that if you do figure out what n is, or if you say like, okay, I want to know the 15th term, you can put n as 15. So this is actually your answer. So let me just label real quick of the colors. I'll start with this green color. AN is still AN. This A1 is this A1, which is this right here. This pink R is right here. I guess I should mark this blue just because in my recursive formula it's also blue. And then the last thing, this n minus 1, I did not touch. So nice, a little rule right here of thumb. Never get rid of n. If anything has n in the equation, just leave it as an. It'll make your life a lot easier. You won't be as confused. Whew. Alright, example 2. The table shown and a number of subscribers. So this is in 7 months. Write the explicit formula and the recursive formula. So first, we have to talk about what is the gap between 7 to become 21. And then 21 to 63 and all the rest of the gaps. And how do I transition from 1 month to the second month, second to third? What do you think? What do you think the rate is equal to? So let me give you another time for Edpuzzle at 1432. Okay, you should have got that this is multiplied by 3. So very simple. So the rate is 3. So I can do explicit. And I can do recursive. if I look back at the equation, which is right here, AN. So I know my first term, right? So this is going to be 7 times 3 to the power of n minus 1 is equal to AN. All I did was plug in my first term, which is right here, first term, and rate. Okay? The recursive form is really just AN, because I don't touch anything with AN, or anything with N I don't touch, or I don't replace or anything, is equal to rate, which is 3, AN minus 1. And once again, this 3 right here is the same rate. We're talking about the same question. We're talking about same data, just writing it differently. Nice. So if you have any questions, please message me on the WebEx. If you have any questions while watching this, just so that I know that you can understand this. But here we go. We're going to talk about a little bit of a harder question, more towards Algebra 2. So writing exponential functions in recursive form. So example 3, the function y equals 8 times 2 to the power of x models the number of E. coli cells y in a petri dish per hour after the start of the experiment. So we're saying that, okay, we're going to start with, well, first, in hour 1, or in hour 0, if I write a table, hour 0 is going to be 8, right? Because 8 times 2 to the power of 0, this 0 represents hours. This is 8. So what about the first hour? How many E. coli cells am I going to have after the first hour? And then the second hour? And then the third hour? How many would you get per hour? So let me write in the question here. For 1725, which is the time. Okay. You should have got 16. This one is 8 times 2 to the power of 2, which is 32. And this is 8 times 2 to the power of 3, which is 64. So this question is actually asking me only for the recursive formula. So really I just need to use this equation right here, which is AN. I'm not going to touch this AN because it has an N, is equal to the rate. Well, what is the rate in this question? 16 to 32, this is times 2. And 32 to 64, that's times 2. So rate is equal to 2. So this is 2 times AN minus 1. Perfect. All I had to plug in was this 2 right here, which is the rate. So really this part of the question, or this question example 3, is just asking you first to find the terms, like kind of like this right here is very similar to this table right here, but you had to figure out the table yourself. And then now you would then find the table, you would find the pattern, then you would write the recursive formula with it. So I would like for you to try example 4 by yourself. What is the answer for number 4, where you have to find the recursive formula? So your answer should be a formula. So the time right now is 19:10. Okay, wave my hand. Here we go. The answer for this is AN equals to 3 AN minus 1. And another nice way, like it's convenient, is because this 3 right here is actually right here. Notice that the 2 for my answer for example 3 is also in the question, or in my formula that it gave me. Alright, 2 more questions to go. Example 5. Example 5 is talking about money again, my favorite. So you invest $500 in a savings account that pays 2% annual interest. Write the explicit formula and the recursive formula to model this situation. So A1 is equal to 500, which is, the principal that we paid. But instead of getting 100%, well, we get 100%, right? Because we get our money, $500, but we get an additional 2%. So we get 2% more. So it's 102%. And the way that I can write that is by like this. Boink, boink. This is equal to 1.02. So I'm going to multiply this by 1.02. This is $502. Or $510, sorry. A2 is equal to 500 because I'm still having that same 500, but I'm getting my 100. Now it became $510, but I still need to get my 2%, which is, well, let's just say I don't know. Let's move on. 500 times 1.02 times 1.02 times 1.02. So if you see this pattern right here, what's really happening in this question, why can this not change? I don't know. You see 102%, then you see 202%, now you see 3. So these are all reflective off of the term value. It's just very conveniently happening like that. So really I can write this as my E is equal to 500. So the rate is really 102%, or 1.02 to the power of n. And the recursive could be the rate, which is 1.02, a n minus 1. We can also write that A1 is equal to $510. But let's see. So you see how the explicit formula, we didn't use term 1. We used term 0 because $500 is our initial amount, right? Initial is term 0. First year is equal to n equals 1, or first term. So I'm allowed to use the 0 term or the initial term because of this equation right here. So you're allowed to use either or. I could use this one too if I wanted to, but why would I use an ugly number like 510 instead of a 500? It's a lot easier to do the 500. So I would like for you guys to try example 6 now, where it's the exact same type of question, but just different numbers. So this time is 23 minutes and 45 seconds, 23.45, and all right, you should have got your explicit formula as 850, which is your initial, times the 1.03, which is 103% to the power of n. And know that n is equal to number of trials, or trial number, or the sample number. R is 1.03 an minus 1. And I'm going to put parentheses here just because it's multiplying. I guess I should write this better. 1.03. Okay. And that's pretty much it. Oh, we have to write A1, which is the first term, is equal to $875.50. All right, well, that concludes the last lesson before the test. So make sure to do your practice, and I'll see you guys in the class. Peace.